You know, building a calculator seems like a classic beginner project, right? But what if we wanted to build one that's not just functional, but also powerful, responsive, and most importantly, truly safe? Well, today we're going to tear down a React project that does exactly that. We're going to see how it's built, from the clean UI all the way down to its super secure brain.
And that's really the big question, isn't it? It's one thing to make an app that looks like a calculator. It's a whole different ballgame to make it robust, intuitive, and totally locked down against common web vulnerabilities. So, before we start taking it apart, let's just take a look at the final product. This is a modern React calculator, and it's pretty slick.
And right off the bat, you can see this thing is packed with features. You've got your basic arithmetic, parentheses, full keyboard support, the works. But that last one, a safe expression evaluator, that is the secret sauce. That's what we're really here to talk about, and we'll get to it, I promise.
Okay, so where do we even begin? Let's start with the part we can all see, the anatomy of the UI, and how this clean, responsive layout is actually put together. So, the whole philosophy behind React is building your interfaces out of these small, manageable pieces called components. Seriously, think of it like building with Legos. Instead of one giant, messy file, you build with these small, clean, reusable bricks. It just makes everything so much easier to handle.
And you can see that structure right here. At the very top, you have app.jsx, which is kind of the main box holding everything. Nestled inside that is the calculator.jsx component. That's the visual shell and also the brains of the operation. And then you have this tiny button.jsx component that gets reused for every single button on the screen. Simple, right?
And that is really the magic of it all. By focusing on these little, simple pieces, the final result is this incredibly powerful and polished interface. It's just a perfect example of component-based design in action.
All right, so the UI looks fantastic, but right now it's just a pretty picture. The buttons don't actually do anything. So how do we bring this calculator to life? This is where the logic comes in.
The key ingredient here is something in React called state. If you're not familiar, useState is basically a component's memory. For a calculator, it holds the current string of numbers and operators, we'll call it expr, that you see up on the display while you're typing. And this table breaks it down perfectly. When you click a button, that action calls a function, and that function's whole job is to update the state. So say the display shows 12 plus, and you click 8. That calls the append function, and bam, the state now holds 12 plus 8. Then you hit the equals button, the compute function runs, and the state becomes the answer 20. It's a really clear, predictable flow.
And these functions are the real workhorses inside our calculator component. You've got append to add characters, del to act like a backspace, clear all to start over. You get the idea. Each one does one specific job, and they all work together to manage that expression on the screen. Okay, this is it. We've arrived at the most critical part of this entire project, the safe evaluation engine. We've got our user's input string, maybe something like 2 plus 3 multiplied by 4. Now, how do we actually and safely calculate the answer? Let's look at the brain of the operation.
This brings us to a huge fork in the road. There's the dangerous way, using JavaScript's built-in eval function. Sure, it's easy, but it's a massive security hole because it will literally execute any JavaScript code someone types in. Not good. Then there's the safe way, building our very own parser that only understands math and nothing else. That's the pro move.
And the developer of this project makes it crystal clear. They've explicitly avoided eval and instead are using a much more robust method, a safe tokenizer, something called the shunting yard algorithm, and a format called RPN. So what in the world is this shunting yard algorithm? Well, think of it as a translator. It takes a math problem that's easy for us humans to read, like 3 plus 4, and it converts it into a format that's way, way easier for a computer to execute. That computer-friendly format is called reverse Polish notation, or RPN for short. And the whole process breaks down into 3 simple steps. First, we tokenize. We just take the input string and break it up into individual pieces, or tokens. Then we reorder. This is where the algorithm does its magic, rearranging those tokens into that computer-friendly RPN format. You can see how 2, 3, and plus end up together. And finally, we evaluate. The computer just crunches through that reordered queue step by step, and boom, you've got your answer. And here's another huge win for building our own evaluator. Awesome. Built-in error handling. So if a user tries to divide by 0 or they forget a parentheses, the app doesn't just crash and burn. It can actually catch the error and tell the user what went wrong.
Super professional. Now, here's a small but really clever detail. All the results are rounded to 12 decimal places. Why? Well, it's to prevent those weird JavaScript floating point errors you've probably seen, where zero point 0.1 plus zero point 0.2 equals some crazy long number. This just ensures the output is always clean and exactly what you'd expect. So we've gone from the UI to the logic, all the way down to the secure engine. Let's wrap this up by looking at how you can take this from a project on your machine to a full-on launch. And this is just the beginning, right? The foundation here is so solid. You could easily add memory buttons, scientific functions, a history panel. Heck, you could even add themes for light and dark modes. This project is a fantastic jumping-off point for something even bigger. And getting this thing online is surprisingly simple. It's basically 2 steps. First, you run the build command, which packages up all your code into a neat little bundle. Then, you just deploy those files to a hosting service like Vercel or Netlify, and your calculator is live for the world to use. Ultimately, this project isn't just about building a calculator. It's about learning how to handle user input safely and securely, a fundamental skill for any web developer. So the real question is, now that you know how to do it the right way, what are you going to build with that knowledge?